All right, we have here another differential equation, and we are asked to solve this. And assuming you have tried already several methods, but you failed to solve it using those methods that you have learned, like the solution of an exact DE, or using the method of solving variable separable DE, or homogeneous DE, or linear first order DE, and you fail to solve this equation using those techniques. And now let's try one more time. Let's see if this is a Bernoulli equation, but by looking at the given equation, or just at a glance, we can say that this is not really in the form of Bernoulli equation, because Bernoulli equation is given in this form: y prime plus function of x multiplied by y equal to another function of x multiplied by y to the n, right? So at first glance, we can say that this is not a Bernoulli equation. But let's see if we can manipulate the given dE and transform this into this one. If we are going to divide both sides by dx, so what will happen? This will become x squared y to the fourth minus 1 multiplied by dx. So let's divide this by dx. And let's do for the other term, x cubed y cubed dy. So divide this by dx, and on the right side, 0 divided by dx, that's still equal to 0 on the right side. But here we have dx and dx cancels out, so leaving us x squared y to the fourth minus 1 for the first term, then plus we have x cubed y cubed times dy over dx. So this is just the same, right? Equal to 0. Okay, we have already dy over dx, which is, this one is just equal to y prime. Now, if you are going to divide both sides by the coefficient of y prime, so what will happen? So we have x squared y to the fourth minus 1. If we divide this by the coefficient of y prime, which is x cubed y cubed, then plus, do the same for the second term, x cubed y cubed dy over dx, then divide this by x cubed y cubed equal to 0 divided by x cubed y cubed. So again, the right side still equal to 0. And our first term on the left side, we can divide this. We have two terms. We can divide this individually by x squared y to the fourth, divide this by x cubed y cubed minus 1 over x cubed y cubed plus, so we have here x cubed y cubed cancels out with x cubed y cubed at the denominator, leaving us this one, dy over dx, which is, okay, we will rewrite that later, dy over dx equal to 0. Okay, now rearranging and transposing this to the other side, this one, then write this first. So we have dy over dx, then this is understood to be positive, so plus x squared, where, okay, just rewrite it, x squared y to the fourth over x cubed y cubed equal to, this becomes negative, becomes positive, 1 over x cubed, y cubed. Then we have here x squared, we have x cubed. Then we have y to the fourth, y to the third power. So we can rewrite this as dy over dx plus, so this one, we have y left, and in the denominator we have x equal to, this one we can rewrite this as x to the minus 3, y to the minus 3, no? From the laws of exponents, which is we have 1 over x to the m. When you raise that up, x to the minus m. Or if you have 1 over x to the m, y to the n, that's the same as x to the minus m times y to the minus m. So from the laws of exponents. Okay, now we can rewrite this as y prime plus, because this is exactly equal to y prime. That is y prime. Then we can rewrite this as 1 over x times y equal to x to the minus 3, y to the minus 3. Now if you compare this with our standard form of Bernoulli's equation, we have y prime plus p of x times y equal to q of x times y to the n. So we can say that our p of x equal to 1 over x. So this is indeed Bernoulli equation. And our q of x is simply equal to x to the minus 3, and our n is equal to negative 3. Okay? So from here, we can solve for our integrating factor, where our integrating factor I of x is equal to e to the integral of 1 minus n times p of x dx. Substituting, we have e to the integral of 1 minus, our n is minus 3. Then times p of x, which is 1 over x multiplied by dx, or equal to e to the, this becomes 1 minus minus, so it becomes plus, so integral of 3, 1 plus, so this is 4, okay, times dx over x, or equal to e to the, put the constant outside, we have dx over x. Okay, and then we can rewrite this as e to the 4 times ln x. And again, from the properties of logarithm, we can put this one here. So equal to e to the ln x to the 4th. And further, again, in algebra, in our properties of logarithm, we can write this as x to the 4th times ln e, where ln e is equal to 1. So therefore, our integrating factor is simply equal to x to the power 4. Okay? Then substituting in our general form, what is our general form of our solution? Or general solution. So the general solution, or the general form of the solution of this Bernoulli equation, is given by this equation. Y to the 1 minus n equal to 1 over the integrating factor multiplied by the integral of 1 minus n times q of x times I of x dx, then plus c. Then substituting, we have y to the power 1 minus 3 equal to 1 over x to the 4th power times the integral of 1 minus 3, then times q of x, where q of x is equal to x to the power minus 3 times I of x is x to the power 4. So times x to the power 4 times dx, then plus c. Or y to the power 4, 1 minus 3 equal to 4, equal to 1 over x to the power 4 times the integral of 1 minus 3 is equal to 4 times from the lowest exponent. So they have the same base, so we can combine this. From the lowest exponents, we have x to the power m times x to the power n equal to x to the power m plus n. So in this case, we have our exponents x to the minus 3, then plus 4, which is equal to x to the power 1, or simply x. Okay, so this is 4x, then times dx, then plus c. Okay, so y to the 4th equal to 1 over x to the 4th, then put the constant outside, integrate x times dx plus c, then from the power formula, so this is equal to 4 times x squared over 2, then plus c. Okay, so we have 4 divided by 2. Okay, I'll continue here. Let's continue it here. So we have y to the 4th equal to 1 over x to the 4th, then times, this becomes 2x squared plus c. Okay, then distribute and multiply. So this one, you distribute and multiply. So we have y to the 4th power equal to, this becomes 2x squared over x to the power 4 plus c over x to the power 4. Y to the 4th equal to, this becomes 2 over 2 over x squared plus c over x to the 4th. All right, or you can simply factor out. Actually, this can be your answer already, but we can still simplify this one. So at the right side, we find the LCD, which is x to the power 4. So this one divided by this, so we have 2x squared plus this one divided by this times c, and we have y to the 4th. Then cross multiply, so we have x to the 4th, y to the 4th equal to 2x squared plus c. Or if we transpose this to the other side, so we can express our answer as x to the 4th times y to the 4th minus 2x squared equal to c. So this can be another form or expression of your answer. Okay, so that's the other example. And I hope you were able to follow our solution. And if you have any questions, you may just leave your comments or your question in the comment section below. Thank you.